we will now look into LTE Introduction, where LTE stands for long-term evolution. First, the requirements, which are based on the data rates. The downlink data rate target is 100 megabits per second, and the uplink data rate target is 50 megabits per second. It has to have low latency, less than 5 milliseconds, and high spectral efficiency. In addition, spectrum flexibility, meaning that given the bandwidth that is given to you, based on the users that need more, some users need less, you can dynamically and adaptively adjust how much you support to the individual users. Comparing this to the fourth generation technology, LTE Advanced, or for short LTE-A. The target data rate becomes 3 gigabits per second for downlink and 1.5 gigabits per second for uplink. As you can see here, for the downlink and uplink target data rates are in the gigabits per second range, where for LTE we were in the tens to hundreds of megabits per second, a dimension of a difference there. So therefore, as you can see, these data rates qualify as fourth generation technology. That is why LTE is considered true 4G technology. In addition, based on Release 8, the spectral efficiency was at 16 bits per second per hertz, where the new Release 10 standards enabled it to go up to 30 bits per second per hertz. And this is Release 10 standards are the core standards for LTE. In addition, an increased number of simultaneous active subscribers can be supported. This is possible because the target data rates of downlink at 3 gigabits per second, uplink at 1.5 gigabits per second, due to the broader bandwidth that was provided in data rate, this could be shared by more users, and therefore an increased number of simultaneous user support is possible. In addition, improved performance at cell edges, at least 2.4 bits per second per hertz per cell. So this shows another specification that is a very important improvement. This is because at the cell edge is where the signal is the weakest. That's where handover is required. That is the so-called weak point, the bottleneck, the Achilles heel of any mobile communication technology, because that's where the signal is the weakest and the performance is the poorest. So, what is the minimum level of quality that I can support at my weakest point determines my overall quality, as in terms that that weakest point would be my lower bound, so my performance would be my lower bound and above. So therefore that specification is very important. Looking into 3GPP specifications, first, let's compare them a little bit side by side in this table. First of all, LTE based on Release 8 and LTE-A based on Release 10 and beyond, where the downlink data rate is for LTE 300 megabits per second, for LTE 3 gigabits per second, a significant improvement. For the uplink, it is 75 megabits per second. For LTE, it's 1.5 gigabits per second. For the downlink spectral efficiency, it is at the range of 16 bits per second per hertz, where for LTE-A, it is at 30 bits per second per hertz. For uplink spectral efficiency, LTE is in the range of 4.32 bits per second per hertz, where LTE ranges into the 15 bits per second per hertz. Significant improvement. Bandwidth-wise, LTE-A can use 1.4 megahertz, 3, 5, 10, 15, 20 megahertz bands, where for LTE you have much more flexibility in a continuous way. So you can provide the right amount of bandwidth to the user by adaptively controlling this. Now we will look into the LTE architecture. The LTE architecture is also what LTE-A uses as well, with some enhancements. And we will talk about that, of course, in the following lectures when I focus more on LTE. But first, the common shared technology is in here, LTE architecture, which is based on a network that looks like this. You see these blocks, And they are divided into big chunks, which has the EPS and the EPC and EU trend written there. Those acronyms stand for, EPS stands for the Evolved Packet System, EPC, which is this top part, stands for Evolved Packet Core, and the EU trend is the lower part, which stands for Evolved Universal Terrestrial RAN, Radio Access Network. Now, as you can see from this structure, first of all, the user equipment, UE, is what we get to use. So therefore, it is very important. It is the most important to us. So we look into it. It will be our smartphone, smartwatch, smart car, like an autonomous vehicle, tablet or pad. It could be like a laptop or PC, as well as an IoT device or a drone. Then for ITS, Intelligent Transportation Systems, as well as CPS, Cyber Physical Systems. In ITS, Intelligent Transportation Systems, there's the onboard unit and the roadside unit devices. And these are the devices that definitely would qualify as user equipment of the LTE network. Then there's the units of the EPS, which include 2 units of the EPC and EU trend, as explained before. Going into some of the details, you can see that these are the 2 units that are included inside, where the EPS, therefore, is like the entire system that is connected to the internet. It includes the unit of the EPC, which is the unit that controls network services and connectivity of the UE, your device, that connects to the internet right here, and the network connections are supported by the EPC. They are the main units, and you can see these unique blocks that have names, which you can see PGW, HSS, MME, SGW, and also PCRF. We will definitely go into the details of these units. Seamless connectivity during handover is supported by the EPC. In addition, the EPC is focused to minimize the packet delay and packet loss. Going a little bit lower is the unit which is called the EU trend, which stands for the Evolved Universal Terrestrial Radio Access Network. This terminology comes from, it is controlling the radio access network. In addition, the wireless channel and the E-Node Bs. The E-Node Bs, in 4th generation mobile communication terminology, this is, we write it as an ENB, which stands for E-Node B, which is short for Evolved Node B. So the word evolved, it's an evolved node B. Well, that means that there must have been a node B before. And yes, there is. In 3rd generation mobile communication, we call the base stations that you see right here, we call them node B. And for short, NB is what we use. Before that, in like 2nd generation mobile communication, like in GSM, well, they used BTS, base transceiver station. The transceiver is a combined word of transmitter and receiver into one word. Then in 1st generation communication, at the beginning, like in AMPS, the base stations were called just the base stations. You may be thinking, why do we have these different names for the same unit that is used to support the cell? Well, it was intentionally named something different. The reason is because every time you write a standard, you do not want to have to write 1st generation base station, 2nd generation base station, 3rd generation base station. Instead of doing that, we just give them unique names. And that's what the standardization committees do. When they get together, they give it a name that is unique. So when they say that name, Evolved Node B or Node B, just by listening to the name, you know exactly what standard it belongs to, 4G, 3G, 2G, 1G. In addition, you know the basic set of functionality, data rate, and other requirements that are included. So that's why the names are unique. They were done that way intentionally.